Alright team, welcome to another quick mechanical science video. Today we're going to revisit our old mate direct stress. Now the scenario I've got here, I've got a bolted connection, needs to withstand 80 megapascals of stress after a load of 10 kilonewtons is applied. Work out the diameter of the bolt that will allow us to connect these materials together. So I've got a little image here which will maybe help us visualise what's happening. So I've got two bits of material, I'm going to connect them using a bolt. What diameter is that bolt going to be? Alright, so it's a direct stress question because we've got this tensile load here. Right, that word tensile tells us a direct stress. But to swap that for the word shear, we'd have to tackle this from a slightly different perspective. However, it means that we're going to use our old mate direct stress, which is equal to force over area. Now don't forget to keep checking your formula sheets or your workbooks if you're wondering where these formulas are coming from. So in this case, we're going to use this, however, we're going to rearrange this formula to work out what A is. And from there, we're going to allow ourselves to work out what the diameter is. Okay, so area is equal to force over stress. And I'm going to go up to my question itself, and I'm going to take information from that. So I've got stress, making a little list, 80 megapascals, 80 times 10 to the 6 pascals, and I've got force, 10 times 10 to the 3 newtons. Okay. So I'm going to put both of these values into this top formula, and I'll end up having 10 times 10 to the 3 divided by 80 times 10 to the 6. So I'll get an area from this calculation, and I'll give you a minute just to pause the video. So my area here, I'm going to get 1.25 times 10 to the minus 4 meters squared. Now if you press your ENG button, you can turn that into engineering notation, so you get 125 times 10 to the minus 6, but I'm not finished with this information, so I'll leave it as 10 to the minus 4 just now. So I've got the area of this bolt. Now what I'm now going to have to do, I'm going to have a little think about my area calculation. Bolts are round, so the area of that is going to be pi r squared. So I've got my area, pi is a constant, the square's a constant, so the only thing that I don't know is the radius. So I'll rearrange the formula. So radius is equal to opposite of squared, square root, oh sorry about the squiggly line there, divided by opposite of multiply, area and pi. So I've got my values, so the square root of the area, 1.25 times 10 to the minus 4 divided by pi. So I'm going to get a radius of, again I'll give you a sec just to pause the video. I'll get a radius of 6.3 times 10 to the minus 3 meters. Okay, so I know what the radius of this bolt is, and it's not a massive leap to work out what the diameter is. So the diameter, and we'll use our diameter symbol, diameter equals radius times 2, so the radius 6.3 times 10 to the minus 3 times 2 will give us a diameter of 12.6 times 10 to the minus 6. The diameters are a linear dimension, so the units are meters. Oh sorry, 10 to the minus 3 that should be. I got a bit carried away there. Okay, 12.3 times 10 to the minus 3. Now, to turn that into millimeters, which might make a little bit more sense for you, is we simply multiply that by 1000, and we'll get an answer of 12.6 millimeters. Okay, so stress gives our area, area gives our radius, radius gives us our diameter. Alright, now I've got a little image on the next slide here. So as you can see, we've got a bolted connection. That's an example of many. Obviously there's more than one bolt in that connection, and that's something we might tap into in future, is looking at a bolted connection with multiple fasteners on it and how that affects how we calculate what's going on. But I just thought I'd introduce that to you. Now, as always, don't be scared to have a little go at this yourself. You could make a couple of numbers up, change the stress value, change the force value, and then see if you can calculate a radius. And as always, you can send me that either through Canvas or you can show me in lesson, and then you can have a little go at that yourself. Alright, so thanks for listening, and look forward to seeing you soon.